We are at the Civil Engineering faculty where the studies of the study field program take place. The building was renovated in 2011. It is equipped with auditoriums, laboratories, a library and other study spaces. There are spaces for students to relax, communicate, individual and group works. Conferences, career and open days, meetings, discussions and festive events take place in the small assembly hall. Graduates take place in the main assembly hall. The equipped and upgraded Auditorium of Engineering Graphics is mainly intended for the first-year students to get acquainted with the peculiarities of engineering graphics, develop spatial thinking, create and analyze two-dimensional drawings, apply the newest standards and prepare graphic documentation. Desks in the auditorium are adapted for the development of these skills. Auditorium 323 is a modern space located on the third floor. Equipped with conference technology, the auditorium has been a successful venue for meetings with Erasmus Plus participants, social partners, student conferences, national and international project meetings, competitions, other events at the faculty. The auditorium is furnished with transformable modular desks that can serve both as points suitable for teamwork, and as individual workplaces. 410 Auditorium is located on the fourth floor, away from the main concentration of other auditoriums. The auditorium functions as a space for meetings, and the remoteness of the place permits students to focus more on the idea they are developing, on teamwork. It has been designed on a mirror principle, this way creating two identical work areas which can be transformed into one ring if necessary. Adjacent is a small room for student relaxation or face-to-face counseling. 409, 162 and other auditoriums are adapted for theoretical, multi-group student lectures. Such auditoriums are equipped for an average of about 80 workplaces, and the lectures that take place here include mathematics, applied research, psychology, construction economics and other. The software in the information technology auditoriums is designed to improve students' digital competencies from the consolidation of basic information technology knowledge and skills formation to development of 2D or 3D digital models using AutoCAD and Revit software. Students of Civil Engineering Study Program prepare construction projects and models, perform simulations and analyze their data, calculate the constructions with Autodesk Robot Structural Analysis software, qualitatively process project documentation, prepare visualizations and make estimates using Systela software. Digital models of buildings created during practical works are printed with the 3D printer, which allows students not only to see the real image of the created project, but also to notice design errors and shortcomings. In the fourth-floor Information Technology Auditorium, students can not only prepare study and project documentation, work with AutoCAD and Revit software, prepare estimates, but also perform structural calculations and prepare needed documentation with Autodesk Robot Structural Analysis software for steel, reinforced concrete, wooden structures analysis and design. Also, in the study process, a thermal camera, a multifunctional device for measuring air velocity and environmental quality parameters, are used to perform individual work and practical workshops, the data of which are processed in these information technology auditoriums. Civil Engineering Study Program students studying the subject Engineering Geodesy and practice use ArcGIS, GeoMap other software to carry out tasks and practical workshops as well. The data collected by the drone is processed by the Agisoft software in these equipped workplaces. Information technology auditoriums are equipped in accordance with hygiene and other regulations, creating comfortable and ergonomic workplaces for students to work. There are also places for working with a personal laptop and places for small groups to discuss projects or discuss and detail printed drawings. Material Science and Standardization Laboratory consists of 2 training areas. The goal of O21 area of the laboratory is to acquaint students of civil engineering field with the requirements of the standards applied in research laboratories, to provide the students with a professional educational area where they could perform their laboratory works as part of the subject building materials. Students get to know the diversity of rocks and minerals that make up the Earth's crust, study their properties and structure, their chemical composition. The laboratory have a large collection of minerals. Laboratory of Material Science and Standardization offers modern laboratory equipment and tools that students use for laboratory work and determination of various properties of building materials. Automated hydraulic press alpha, compression and bending press mega, which allows to perform tests on building material properties and to determine loads that destroy specimens. To assess physical and mechanical properties of materials, students use refrigeration incubator, a device for wear detection, a tensile strength test machine, a stereometric microscope STEMI and ductilometer to determine ductility of bituminous materials. In O22 area of Materials Science and Standardization Laboratory, the properties of concrete mixtures are determined. The laboratory is equipped with a concrete drum mixer, with sets of dismantleable metal cylindrical and cube shapes for the preparation of concrete samples, devices for performing slump test, moisture test, air content test. Students also have access to Webbe consistometer and vibrating tables when performing their laboratory tasks. A Schmidt hammer and an ultrasonic device are used to test hardened concrete. A cement mixer, Vico device, sieve set, electronic scales, measuring cylinders are used to determine the properties of mineral aggregates and binders. Bitumen tests are also performed in the laboratory. For this laboratory work, a device is used to determine the softening temperature of the bitumen and a penetrometer to determine its hardness. Other laboratory tasks require a metal hardness tester, a wood moisture meter, and other laboratory equipment such as electric ovens, an acoustic calibrator, a hydrostatic balance frame, a plaster paint scraper, a plastering machine, a Suttard viscometer, a device for determining the physical and mechanical properties of materials, Parsi test tear tester, adhesion tester, Tabor workplace rotary platform device for wear assessment. The Laboratory of Materials Science and Standardization also organizes professional seminars, guest lectures, trainings for students and educational construction practice. In cooperation with the social partners, a mobile roof construction stand, calculation examples of building partitions and structural units were also installed. The Center for Engineering Systems consists of 2 laboratories, the Laboratory of Thermal Energy and the Laboratory of Engineering Systems. In the Engineering Systems Laboratory, students, by performing laboratory work with the Laboratory Equipment Module, Building Water Management System, simulate the operation of a real building hot and cold water supply system. By analyzing the operation of engineering system equipment, students delve into the processes of hot water preparation, the principles of pressure and temperature regulation in the water supply system. Using the Laboratory Equipment Module, Building Heating System, Students model the operation of a real building heating system, starting, regulating and stopping the heating system. The module demonstrates the hydraulic properties of a heating circuit with a four-way valve. During the laboratory work, students examine the purpose and principle of operation of the circulating pump, thermostatic valves and other components of the heating system. In cooperation with social partners in laboratory, the ventilation system unit with recuperator is demonstrated to the students. The equipment in the thermal energy laboratory is designed to develop students' practical skills and perform experimental research. Laboratory work is performed by students of the Civil Engineering Faculty Building Engineering System Study Program. A specialized software has been installed on the hydraulic process test stand to capture changes in fluid pressure and flow rate with the help of electronic sensors. Instantaneous results and graphs are displayed on the computer screen. While performing laboratory work with a solar collector, students determine the degree of efficiency of the solar collectors. Air conditioning and cooling equipment is controlled by a specialized computer program. Using this equipment, students examine the cooling cycles that take place in cooling machines as well as the air conditioning processes that are displayed on a computer screen at that moment. The heat unit module is designed to form students' practical skills. In this module, students perform the following laboratory works: starting a heating unit for hot water preparation. Heating and hot water preparation. Starting the heating unit for radiator and floor heating. Stand for modeling heat pump operation. During the practical work, students see which parameters have the greatest impact on the heat pump operation process, and can change them to achieve the most efficient result. The Center for Engineering Systems offers practical training, cognitive practice, and guest lectures. Interdepartmental Physics Training Laboratory for students of technical and civil engineering faculties is designed to develop students' experimental skills for work with the modern equipment. To provide knowledge about methods of measuring physical quantities, processing of experimental results, their computer modeling, presentation and evaluation of measurement errors. Students perform practical works in various fields of physics, mechanics, acoustics, molecular physics and thermodynamics, electromagnetism and optics. Some works are designed by a computer in a virtual environment, increasing the variations of various physical actions, expanding the boundaries of tasks. At the physics laboratory, practical work is focused on the specifics of the relevant college study programs. The laboratory is equipped with modern laboratory equipment, instruments and tools. It is possible to perform up to 23 practical works from various fields of physics. Civil engineering program students usually practice in the following fields: physics, structural mechanics, acoustics, molecular physics and thermodynamics, electromagnetism, optics. Such activities is study of temperature dependence of metal resistivity and germanium semiconductor resistance. Study of sound waves in various situations, determination of acoustic parameters and etc. can be performed parallelly with conventional devices and computer modeled in a virtual environment. It is possible to increase the variations of different physical actions and to expand the boundaries of tasks in such environment. During surveying practice and practical work, students are provided with knowledge about measurement methods, inspection and adjustment of devices, processing and presentation of measurement results and evaluation of measurement accuracy. All measuring devices are stored in the geocamera, using electronic Topcon and Leica flexible tachometers, automatic Nikon and Topcon levels and a GPS receiver. Students perform surveying, marking and control works in the given area. With the robotic tachometer TopCon and the electronic level Geomax, students perform practical work in a geodesy laboratory. The geodesy laboratory is equipped with a computerized workstation for the transfer of measurement data from a computer. Measurement results are processed using AutoCAD or GeoMap software. During the practical lectures, measurements with a drone Phantom are performed. The image processing is performed with the Agisoft Metashape software. The Laboratory of Geodesy is designed to develop students' practical measurement skills for working with modern surveying equipment. To understand their operating principles and to evaluate technical properties. In the spacious premises of the college library, students can study independently and lecturers can prepare for their lectures, and improve their professional competencies. Students and lecturers can access the electronic resources subscribed by the college library from computers in the college reading spaces or online. The college is a member of the Lithuanian Research Library Consortium and participates in the project of this organization, opening of the online research databases for Lithuania. The library subscribes to 3 international databases: EBSCO Publishing, Taylor and Francis Online Library, Emerald Management e-journals collection. The latest information provided in the databases helps to perform various tasks, deepen knowledge independently and achieve the study results of a study curriculum. The college library subscribes to electronic books published by Vilnius Gediminas Technical University Publishing House, Technica, and Kaunas Technical University Publishing House, Technologia. Most of these books are in Lithuanian. The Vilnius College of Technologies and Design Virtual Library is being created through the system of the Lithuanian Academic Electronic Library. The library contains methodological instructions for the course papers, self-study tasks and final thesis of the study program. Student zones are distributed across a few locations of the civil engineering faculty. The largest student zone in the faculty is an open space hall on the basement level, where students can enjoy individual workstations with internet access. The hall also offers a group work area where students can prepare for various presentations in small groups. A lounge area with seat bags and board games. This zone is also equipped with film watching area where students can organize movie screenings, battles or mini competitions in the evenings. The second student zone is located on the 3rd floor, as an enclosed space that provides students with the possibility for individual work and consultations with lecturers, as well as for the meetings with social partners to discuss internship and employment opportunities. Here are several locations with internet access. Apart from being able to read educational professional literature, students can find here the newest information on the offers for internship or permanent work. Other students' relaxation and meeting zones are located in the halls of the 3rd, 4th and 5th floors. A modern gym is equipped for students' needs where students physically develop sports skills and strengthen their health as well as participate in group trainings with professional coaches. The public spaces of the faculty are used to promote students' works. As a rule, these spaces are used to exhibit the results of international workshop projects. After the annual creative workshops, the community and guests of the faculty can get acquainted with the projects prepared by the students, provide observations and suggestions for the future workshops and projects.